Ok, Pythagore. Alors, pour les élèves, vous vous souvenez qu'on a fait Pythagore. And then for parents, Pythagoras. So Pythagoras lived in like the 500s, before Common Era, way long time ago. Before people started to think about numbers as being actual things, like I have a certain number of markers. It would be more like I have 4 blue markers. Holy cow, okay, hold on, these markers. 4 blue markers, and I have 6 other colored markers. So that's a ratio of 2 to 3. It's actually a ratio of 4 to 6, but it could be reduced to, for every 2 blue, I have 3 of another color. So that's how they understood numbers. And what ended up happening is these ratios were how he ended up coming up with this. And actually, Pythagoras traveled to Egypt, and he noticed that the Egyptians were making these beautiful pyramids and making other beautiful structures, and they were able to come up with these extremely straight walls using a rope with 13 knots on it. And what they would do is they would take the rope and make it like this and make it into a perfect right angle. And a right angle, for those of you who didn't find this out before, is 90 degrees. So something that is a circle is 360 degrees, right? We all know that. We did a 360. That means a circle. So what's half of 360? It's 180. So if we took away half of the circle and we were talking about a straight line, that would be 180. So that's an angle of 180. Well, if we cut that in half, and now we're talking about just one arm of it like this, this is half of 180, which is, of course, 90. So this is a 90-degree angle. And if you think about what 90 times 4 is, it's 360. Okay, so back to Pythagoras. So Pythagoras went to visit the Egyptians, realized they did this, and he said, well, how are you doing this? And they said, well, we don't think about how we're doing it, we just do it. So then he went back and he started thinking, okay, well, on this side, there would be 3. 1, 2, 3. And then that would be a ratio of 3 to this side, which would have 4, which would then be a ratio to this side, which is 5. How is that working? How are they doing this? Okay, so then he started thinking, well, if I had 2 of those, would that equal the same as this? No, it would not. If I had 1 of them, okay. And he kept trying to do all these different things. And then finally he realized it wasn't about triangles, it was about squares. So then Pythagoras made each of these sides into a square. So when you make something into a square, what do we know about all 4 sides? They're all the same length. That's what a square is. So a square with 4 sides of 4. So this original triangle had one side length that was 4, one that was 3. So he had another square here that was smaller. It was a 3 by 3. And then he had the biggest square across from the right angle. And that was a 5 by 5. So if we did the area inside of each of these squares, or said how big they are, 3 times 3 is 9. 4 times 4, or 4 squared, since we're doing exponents, is 16. And that actually means make it into a square. And 5 squared is 25. What do you notice about the 2 smaller squares and the larger square? If we take the area of the first square and add it to the area of the second square, we get the area of the third square. And this is a major, major finding. So this is so amazing because, and in our classes what we did is we cut these up and then we put them in here. Like we cut this into 16 equal small squares and this into 9 equal small squares, and then we put it in here and it would equal 25 of the exact same size little small squares. So this mathematical proof allows us to do so much math. Okay, so if we take the 9 and the 16 and the 25, now that's the area of the squares. Now let's get back to the triangles. What are the side lengths? Well, the side lengths are the square root of each of these. So the side lengths are, let's call this is the hypotenuse. So we have the hypotenuse. L'hypoténuse est ce côté qui est le plus long. It's always the longest side, and it's always directly opposite the 90-degree angle. That's the hypotenuse. Well, we are going to call this C. And C in this case equals 5. Well, let's go over here. we're going to call this side A. And A in this case equals 3. And this side is going to be B. So this is as easy as ABC. And it is 4. Okay, so how did we get this if we're using these variables? Well, we would say that we had A squared, because 3 squared is 9. And actually, the way that that was written with the square roots would not be an equality. So it's good that I erased that. So this is A squared, or 3 squared, plus this guy, B squared makes 16, and A squared plus B squared equals this guy squared, C squared. That makes sense, right? So then, a lot of time later, we started calling this the Pythagorean theorem. And you've probably seen this, where C squared, I hope you've seen this semester. C squared equals A squared plus B squared. But that's what it means. It's actually talking about squares, their areas, and the side lengths that make the triangle, the right angle triangle. And you can only use this with the right angle triangle. Okay, so it has to have that 90-degree angle. It has to have a hypotenuse. So let's try one. Now that we understand where it comes from. So let's do one that looks like this. I made a question about Rome and Milan and all that, and some students got it wrong because they didn't read the part that said that from here to here was shorter than this, which would have told them that this had to be the hypotenuse because it's the longest side. So let's say we have, let's call this 5 units, or let's say meters, and let's call this 12 meters. How can we find the hypotenuse, the longest side? How can we figure out what C is? So we remember that C squared equals A squared plus B squared. Well, we don't know what C is. I'm going to call it X. Because I could say that this was C. I could call this Santa Claus. I could call this whatever. It doesn't matter. This is just a way to think hypotenuse squared equals leg squared plus leg squared. En français, on dit pas leg, on dit cathète. Des cathètes. Okay? These are the legs of the right angle. Okay. So x squared is equal to 5 squared, or A squared, plus B squared. Okay, so 25 plus 144 equals x squared. 25 and 44 is going to give you 169 is x squared. Well, we know that this is not 169 meters because that would be so much longer than this that it just couldn't even possibly exist. So at that point, you should have alarm bells ringing if this is your final answer, because this is not this. This number is the area of the square that we could bump up against this, right? That would be, that square would be 169 meters squared. So that means that the square root is that side. So this would be 144, this would be 25, but their square roots are 12 and 5. So what is the square root of 169? And the square root of 169 is 13. So this one is 13, this one is 12, and this one is 5. Hopefully that helps. But just wait, there's more. What happens if I knew that was 13, but I didn't know that that was 12, and I wasn't sure? So let's call this x this time. So this is when you can't just add the two sides together because we don't know what this one is. And our big side is the one that these two go into. So if I told you my big side was 15, and that equals my two small sides, which are 8 and 7, but I didn't know one of them, how could you figure it out? You would say, what plus 7 gives you 15? Or 15 minus 7 is equal to the one we're missing. So we're going to do the same thing here. We're going to take the big one and subtract this one to figure out what this one is. So the big one is 13 squared minus a small one will equal the other small one. That makes sense. Some teachers will actually even write this out so that you can just plug and play. So all of these formulas, whoops, will get you the answers that you need. But if you understand why and how, you don't even need to worry about these formulas. You just have to remember that this square is equal to these two squares. Okay, so this big square 13 is going to be 169. And if we take out a chunk of that, this small square, if we take out the equivalent of one small square, we'll get the rest, which is equal to this guy. So this is 25. Okay, so what's 169 minus 25? It's 144. That's the area of this square. Take the square root of each of them. So we take the square root of x squared, that gives us x. We take the square root of 144, that gives us 12. So in this case, x is 12. So sometimes you subtract and sometimes you add. Basically, when you have the hypotenuse, you're going to have to subtract because you have the big one. When you don't have the hypotenuse, you're going to have to add because you have to add the two little ones to figure out what the hypotenuse side is. Okay, I think that's everything, but you can send me more messages on Teams, and I can make another video that will explain a different concept, but I think that's everything that you had for your exam. Good luck, guys.